Geometry, Unit 7, which is Chapter 5 from the book, Section 1, Polygon Sum Conjecture. Regular polygons, all the angles are the same for each polygon that has the same number of sides. And we can see this concept demonstrated here. Both of these polygons have 5 sides. So regardless of how large or small the regular polygon is, if it has the same number of sides, its angles will be the same. So every single angle in these two regular pentagons will be congruent. Again, regardless of how large or small. So it's interior angles, which are on the inside, will be congruent, and the exterior angles, which are on the outside, will also be congruent. And remember, interior and exterior angles form a linear pair. So the triangle interior angle sum, we know, is 180. We've proved that before. So we know the sum of all 3 angles, regardless of the size or shape of the triangle, is 180 degrees. If it's a triangle, we know it's 180. We also have done the same concept in a quadrilateral. We know the quadrilateral sum is 360. Now you notice each of these has a line drawn on it, connecting one diagonal. It doesn't matter which diagonal you chose. We can prove the interior angles of a quadrilateral is 360 because we know the sum of the interior angles of a triangle is 180. So this quadrilateral got split up into 2 triangles. So we know those are 180. These 2 triangles are 180. And we know these 2 triangles are 180. Well, we know the sum of the interior triangles is 180. So 2 triangles together, the sum of those interior angles is 360. We can use this idea to figure out all of these polygons. So here we got a pentagon. We split it up into 3 triangles. We know the sum of those 3 triangles is 540. We can do the same thing here. So we've got a hexagon splits up into 4 triangles, which adds up to 720. A heptagon, 7 sides, splits up into 5 triangles. You know, this is a common theme. The number of sides that splits up into is 2 less than the number of sides. So that's 5 times 180, which is 900. And then here, an octagon, 8 sides, we can split up into 6 triangles. So again, the number of sides directly relates to how many triangles it splits up into. And so all 6 triangles add up to 1080. So the sum of the interior angles of an octagon is 1080. So the polygon interior angle sum we can calculate for any polygon for any number of sides. It's 180 times the number of sides minus 2. So here, we got 12 sides. That's 180 times 12 minus 2. So that's 180 times 10. So that's 1,800. And then we've got 20 sides. Again, that's 180 times the number of sides minus 2. So that's 180 times 18, which is 3,240. That's the sum of the interior angles of a 20-sided polygon. So we can use that knowledge to solve for some unknown angles. Now notice these are not regular polygons. It doesn't matter whether it's regular or not. The sum of the interior angles is always consistent. So here we've got 5 sides, so that's 180. 5 minus 3, so that ends up being 540. So all 5 of these angles add up to 180. So x plus 78 plus 126 plus 105 plus 83 equals 540. Subtract all of them, and you get x is 148 degrees. And the second polygon, we've got 1, 2, 3, 4, 5, 6 sides. So 180 times 6 minus 2 So that ends up giving us 720. And we get 2y, why 2y? Because there's two of them there. 2y plus 105 plus 144 plus 102 plus 135 equals 720. And so we end up getting y is 117 after we subtract and solve for everything. All right, so let's look at an application of this idea. We can use it to prove that we're going to get a correct answer here. So we've got a regular polygon, and we can see its interior angle. The question is, how many sides does it have? Now, it's hard to tell because the polygon's covered up, but we can use some ideas that we've previously solved for. So this here is an exterior angle. We know exterior and interior angles add up to 180 because they're a linear pair. So our exterior angle is 60. Now we know the sum of the exterior angle on any polygon is 360. We've proven that before. So to solve for how many sides it has, if we take the sum of the exterior and divide by a single exterior angle, that will give us the number of sides, which here is 6 sides. Now I can use the concept that we worked through in this section to prove that it is 6. So if I take 180 times the number of sides minus 2, that ends up being 720. Now if I divide by how many sides there are, 6, that gives me the interior angle, which is 120 degrees. And that is the end of this section.